Thermal performance of unfired clay bricks used in construction in the north of France. Objective. The objective of this study is to demonstrate and to study the sustainability and the qualities of the earthing construction in real conditions. Uh, Firstly, the identification of raw materials was performed in order to study the mine's properties of these building materials. Um, the second part of this work presented an experimental study conducted to investigate the dynamic thermal performance of unfilled clay bricks. The construction sector in France consumes almost half of the final energy. It generates almost a quarter of the country's greenhouse gas emissions. These new standards promote the widespread construction of low energy buildings. Advantage: studies show that building and maintaining an adobe house save a lot more compared to conventional materials. Um, it can reduce CO2 emission by 101 tons per year. The construction of Earth presents economic benefits. A particle size distribution was determined using a wet shaping and a sedimentation test. With the results, it can be observed that the soil can be classified as low plasticity soil. The briqueteers do not company produced unfired clay bricks using the raw material characterized previously. It is produced according to artisanal techniques, and it is shaped using a vertical mixer and wooden mold. An experimental study was carried out to investigate the thermal properties of unfired clay bricks. During the construction phase, the building was protected against bad weather. After the foundation were laid, the first two rows of walls were built using brick walls intended to protect the raw earth walls from capillary rise. Uh, the thickness of earthing walls varied from 460 to 600 millimeters. Um, the walls were often with temperature sensors in order to characterize the thermal behavior of unfired clay bricks under real conditions and to study the indoor thermal comfort. And the building was monitored for a full year. In this slide you can see the photographs of temperature against time and the results that the temperature sensors showed, with the red and blue line to different the internal and external changes respectively. In the two graphs above that correspond to winter time, you can see that the two lines, both blue and red, have a lot of variation. But in the next two that correspond to summer, the external changes are more pronounced than the internal ones. These are much clearer photos of how the foundations were cast in 20 square meters to avoid marking building permitting and also how a few centimeters of clay bricks were used to protect the mud walls from water to due to bad weather. Some of them were made with lime and covered with natural clay gypsum, and outer wooden skin has been used to protect other walls. After the thermal retardation test, it was discovered that walls were required with a thickness ranging from 400 to 600 millimeters. Um, Here we can see the walls already under construction with these standards. Here are the sensors that were used to know the external and internal temperature changes, and with which the results already mentioned were determined. Conclusions: 1. The dynamic thermal characterization of unfired clay bricks showed that the optimum thickness of earthen wall is equal to 400 millimeters. 2. It ensures a reduction of the fluctuation of the outdoor temperature, of a limitation of the risk of overheating the building. And 3. The campaign of measurement tests performed on the two walls of this experimental building has confirmed the role of earthen materials in mitigating the fluctuation of outdoor temperatures. And